Hello, Windows Analysis. We explore the Windows universe, performance, hidden settings, history, hacks, and updates. If you like understanding your system, stay tuned.
All right, let's get right into it. It's something you do every single day. You hit the power button, and, a few seconds later, bam, your desktop pops up. To us, it feels almost instant, doesn't it? A simple flick of a switch, and everything just springs to life. But the reality is, what's happening under the hood is this brutal, high-stakes, super fast sequence of operations. So today, we're going to pull back that curtain.
You can think of it like this. Your computer is waking up from a deep sleep. It's going from completely cold and inert to fully functional and ready to go. And this entire process, this whole transition, it all kicks off with just a single spark of electricity. That one little spark starts a whole cascade of events, a perfectly synchronized ballet between hardware and software. And we're going to break it down step by step.
And right off the bat, here's our first big surprise. The very first piece of software that runs on your computer, it is not Windows, not even close. It's actually the firmware, the software that's permanently part of your motherboard. On modern PCs, we call this UEFI, and you can think of it as the primitive brainstem of your computer. It has one single job: to make sure all the vital hardware is there and working before it hands off control to anything else.
And this process? Oh, it's incredibly methodical. It's like a strict 4-phase checklist that it has to run through. First up, in the SEC phase, it sends a jolt to the CPU to wake it from its slumber. Then, in the PEI phase, it gets the system RAM ready to go. Next, in the DXE phase, it loads the absolute most basic essential drivers. And finally, once everything checks out, it hits the BDS phase, where it finds the Windows Boot Manager and basically says, all right, tag, you're it.
Now, you might be wondering, why is it so rigid? Well, there's a really, really good reason for that. It's all about guaranteeing the hardware is reliable. See, if anything fails during this super early stage, like a bad stick of RAM or a CPU glitch, Windows won't even try to start. The UEFI acts as a firewall, a critical quality control check that prevents, countless problems in blue screens later on. It's literally the first line of defense.
So, once UEFI has done its job and given the hardware the all clear, we get to the main event, the handoff. Control passes from the firmware to the operating system. A little file called winload.exe takes the baton. But hang on, because this is where the real drama begins. In today's world, booting up isn't just a race for speed, it's a race for security. And this quote right here, it just absolutely nails the modern challenge. To win the security war, you must first win the race at boot. Think about that for a second. Every single time you turn on your PC, there's an invisible race going on. It's a sprint between your operating system and any potential threats. And whoever gets control of the system first, well, they win. And attackers are masters at exploiting this race. This slide lays out the modern battlefield perfectly. See, the whole game for malware is to load before the operating system itself. And why is that? Because if it pulls that off, it becomes a ghost in the machine. It can hide in the deepest parts of the system where the antivirus, which loads way later, will never even see it. So Windows's goal is simple: win that race. Secure the system before anything else has a chance to. So to win this race, Windows brings out its champion, the Integrity Manager. And its design is just pure genius. It's built to be the very first driver that loads. It's like the bouncer at the coolest club in town, checking the guest list before anyone even gets near the door. But how does it guarantee it's first in line? Well, it uses a special DLL to intercept the list of drivers that are about to be loaded, and then it literally rewrites that list on the fly to put itself at the very top. It's a brilliant, decisive move to lock the system down from moment one. And we're not talking about it protecting, minor stuff. No. We are talking about the absolute crown jewels of the boot process. As you can see here, this is the entire blueprint for what's about to happen. The full list of every driver, critical info from the BIOS, the system's memory map, even security data from the TPM chip. By grabbing and securing this blueprint first, it locks down the entire boot plan and just slams the door shut on deep-level threats like rootkits.
Okay, so the hardware's verified and the system is secure. Now we're in the home stretch. Windows finally takes the wheel. You can think of this final part as a kind of assembly line, where a few key processes work one after another to build the desktop environment we all know and love.
With the Windows kernel now fully in charge, this final assembly line kicks right into gear. First up, sas.exe gets launched. This is the process that's just listening for you to hit Ctrl-Alt-Delete. It's the gatekeeper. Once you're authenticated, winlogon.exe takes over to handle the actual login and load up your user profile. And then finally, usernet.exe comes in to do the heavy lifting. It runs any login scripts and loads up your shell, which, for most of us, is that familiar desktop with all our icons and wallpaper. That's the chain reaction that brings it all to life.
So we've gone from a single spark of electricity to a fully working desktop. I mean, this whole sequence is just a marvel of engineering, right? But it's not just about making it work. It's about making it work fast. In the boot process, every single millisecond counts, and you'd be shocked at the difference a little optimization can make. And if you don't believe me, just check out this data from Intel. An unoptimized system takes almost 9 seconds just to get through that initial hardware phase. With some smart optimization, though, that time drops to just over 5.5 seconds. That's a whole 3 seconds we just saved, and Windows hasn't even started loading yet.
In fact, check this out. The potential improvement in just those very first hardware phases, the SEC and PEI stages, can be as high as 66%. That is an incredible gain. It just goes to show you that when you're booting up, every single millisecond is gold. And understanding this stuff is how you squeeze every last drop of performance out of your system.
This journey from a powered-off hunk of metal to a secure, fast desktop is absolutely no accident. It's a high-precision sprint, a perfectly controlled race where every single component knows its part. And it leaves us with one last thought. If all of this incredible hidden choreography happens before you even see the login screen, what other hidden processes are running on your system right now? And that's it for today's analysis. If you liked it, subscribe, leave a like, and a comment. Enjoy tinkering, and see you in the next Windows analysis video.